Hi guys, welcome to this page of the notes. What we're going to do here now is we're going to take a look at our third theorem for finding missing angles inside of a circle. However, this time it's going to be the exterior angle measure. So this will be the tangent, secant, exterior angle measures. In the last page, on the last page of the notes, we looked at the tangent, secant, interior angle, where that angle was on the inside of the circle. Now it is the exterior angle, and you'll recognize them. Please notice, right? I have a common endpoint, common endpoint, common endpoint. You are finding the measure of the circumscribed angle. We talked about circumscribed angles back in section 3 of this chapter when we took a look at tangent lines. What is a tangent line? And then circumscribed angles. What is a circumscribed angle? And we didn't actually really do any algebra with those ideas. We just gave you some things to think about with tangents and circumscribed angles. I told you they would show up later on where you'd actually have to find those circumscribed angles. Here it is. Here it is. We're trying to find the measure of those circumscribed angles. Now, this one's a little bit trickier than the other ones because there are 3 different cases. So, first, the theorem. All right, here's the way it works. There are 3 different cases. This is going to be case 1. You have case 1 if it is a secant line and a tangent line. So this would be a secant tangent. Secant tangent. This is case number 2. This is if, look. This is if you have 2 tangent lines. So this would be tangent, tangent. And then you have case number 3. And look, secant line, secant line. So this is if you have a secant, secant. Okay, so for these secant, or for these tangent, secant, exterior angle measure theorems, there's actually 3 different ways these problems could go. There's 3 different cases. Based on the diagram you're given, you'll have to decide which case you've got, which of these is the one you're working with, and pick the proper formula, or use the proper formula. And then one more quick note, actually really important here. All these formulas, which I will talk about in just a second. There are 3 different formulas depending on which case you have, depending on whether it's the first, second, or third case. But here's what I want to point out. Please notice subtraction, subtraction, subtraction. When it comes to subtraction or a difference, you're subtracting 2 numbers, order matters. Subtraction is not commutative. If you switch the order, you will not get the right answer. So very important for these problems, the order does matter. And the reason order matters is because subtraction is not commutative. You must put those guys in the right order. If you switch them, you will get a different answer and it will not be right. So please be careful when you're doing tangent, secant, exterior angle measures. When you're asked to find the measure of a circumscribed angle, right? These formulas must be used exactly the way that they're written. You cannot switch the order of these arcs. Okay, now here's the way that they work. If you're asked to find the measure of, please, I'm not asking you to find a different angle. Look. This is the, all right, find that angle. Find that angle. Find that angle, right? The circumscribed angle, circumscribed angle, circumscribed. So in every case, you're being asked to find the circumscribed angle. The only difference is you have a secant and a tangent of a circumscribed angle. Here you have a tangent and a tangent forming a circumscribed angle. Here you have a secant and a secant forming a circumscribed angle. What's nice is actually all the formulas are really closely related. Please notice, in order to find the measure of the circumscribed angle, it'll be 1/2 arc AD minus arc BD. It is the arc farthest from the angle minus the arc closest to the angle. Same thing. To find the measure of the circumscribed angle, it will be 1/2 the measure of the arc farthest from the angle minus the measure of the arc close. Holy, like they're almost like, right, the same. It's exactly, whatever arc is farthest minus whatever arc is closest, divide it by a 2, multiply it by 1/2, and you get the measure of the exterior of that circumscribed angle. Same thing. The measure of the angle, look, it's the arc farthest, JN. JN minus the arc that is closest, KM. So while it may look like, holy cow, what am I supposed to do? I have to identify which case I have, and then I have to use the formulas are almost all exactly the same. Find that exterior angle, take whichever arc is farthest from the angle, and subtract the arc closer to the angle. All right, that's the way that they go. One other thing I want to point out to you here is this. Please notice in the last section, we got the secant, we had the secant tangent product theorem. That secant tangent product theorem said this: if you have a secant line, you have a secant segment and an external secant segment, and then you have a tangent segment. And the way the theorem worked was, it was this: if you take the secant segment, AC, whatever that secant segment is, you multiply it by the external secant segment, BC, that has to be equal to the tangent segment squared. So, what we've got is, if you're given this diagram and asked to find a missing segment, right? You don't know the length of one of these segments, then you'll use the secant tangent product theorem. Secant tangent product theorem, which was this guy from the previous section. Or I give you the exact same diagram and ask you to find the circumscribed angle. Okay, fine. Then you will use the secant tangent exterior angle measure theorem. All right, so there's two different theorems. One to find a missing segment, one to find the missing angle measure. Check this out. In the last section, we looked at the secant product theorem. The secant product theorem said this: you take the secant segment, JL, you multiply it by its external secant segment, KL, that has to be equal to the secant segment, NL, times its external secant segment, ML. So in the last section, if I give you this diagram and I ask you to find a missing segment measure, you use the secant product theorem to find that missing segment. Or I give you the exact same diagram, I ask you to find the measure of the circumscribed angle, the missing angle measure, then you would use this tangent secant external angle measure theorem to find the missing angle. So the last section and this section going together to help us solve problems, whether it be to find a missing segment or whether it be to find a missing angle, right? Two sections coming together. All right, here we go. Let's do some problems. Whew, we're going to find the value of x. Here we go. Great, what have I got? Please notice I have this guy right here, which is a secant, and I have this guy right here, which is a secant. So, the theorem says this: the measure of angle L is equal to 1/2 the difference of the arcs, the arc that is farthest, so JN, measure of arc JN minus the measure of the arc that is closest, KM. That's it. That's the geometry. That's the formula from up above. Look right here. Secant, secant. It's case number 3. There it is, case number 3. Secant line. That's the formula. Right? There it is. Plug and chug. Don't fat finger something on your calculator. We should be good. They give me the measure of angle L. It's 25 degrees. That's equal to 1/2 the measure of JN, which is 83 degrees, minus the measure of KM, which is what I've